Bienvenidos, Ushamdid, and welcome to this HUD-8 techtorial on Cisco's Enterprise Networking Security and Automation course, or ENSA version 7. In this activity, we're going to be taking a look at Packet Tracer 12.6.1, which is the troubleshooting challenge and sort of the culmination of all of the work that we've done to this point in the course, and the penultimate packet tracer activity for ENSA. Now, it is critical that in this activity you document the network as accurately and as comprehensively as you possibly can, because the final activity of the course, which is Packet Tracer Activity 12.6.2, is going to require you to have the diagram so that you can use it to troubleshoot the issues that you might find in the network. And I'll be showing you my diagram that I've done up here, which I feel would be 100% in terms of a submission that would accompany this packet tracer activity. So let's dive in and see what we're going to be working with here. So here is Packet Tracer 12.6.1. You can see we've kind of got this PC setup here, and then everything kind of goes into this ubiquitous network cloud, right? And it's kind of this mysterious network cloud as well, because we don't know what's in here, and that's kind of our job, is to figure out for these PCs, what are the interfaces, what are the host IP addresses, what are the subnet masks, and what are the default gateways. Again, these are all things that we're going to want to be documenting. Now, in this video, I'm not going to go through all 7 PCs. Rather, we're going to do the first couple of PCs, gather some information up, and then you're going to be set off on your own to go ahead and complete this activity. But everything I'm going to show you, including the diagram that I produced from an investigation of this network, is going to be critical to your success in the final packet tracer activity of the course. So let's go ahead and click on PC1, right? We might as well start here because that is the first PC listed. Now, the internet server that's up here, it's not listed here, but we would add that, right? That's something that we're going to think about adding. Now, I can come to the IP configuration, and I can quickly pick off the IPv4 address, the subnet mask, the default gateway, and even the DNS server that's going to be used. And so for PC1, I could fill that information in here. Now, it says interface NIC. Well, let's take a step back here. Let's go out to the command line, and let's talk about some command line commands that I could run. I could say ipconfig, and let's give ourselves a little more room here. I could say ipconfig, and take a look at the information we see. We see the EUI64 link local address. We know it's EUI64 generated because of that Fox Echo, those hexadecimal characters in the middle, sort of in the middle, of the IPv6 address. We have our IPv4 address, the subnet mask, and the default gateway, so we've got quite a bit of information here. But what if I was to say ipconfig /all? Because I'm curious, I want to know the MAC address of PC1, and you're going to see why that's going to be important here in a second. Now, I know the MAC address ends in Delta 737 because the EUI64 generation of the link local IPv6 address is leveraging that uniqueness of your 48-bit MAC address. And so if I say ipconfig /all and hit enter, here is the physical address. In other words, here are the 48 bits. Right now, we're being shown hexadecimal characters here. And remember, there's 12 hexadecimal characters. Each hex character takes up 4 bits. 12 times 4 is 48. So that's where I get that 48 bits from. So we can see the MAC address, the physical burned-in address on the Ethernet card, or the NIC card, is 000 Charlie, Charlie Fox 0 Alpha, and you might want to even add in another column in here to capture this information. And here's why it's going to become important, because we need to be able to identify if the PC plugs into a switch, on which port is that PC connected. So think about that, because again, we're trying to document as much as we can here to help us in the final activity. So now I've got the MAC address of the PC. Well, if I scroll down a little bit further, you can see we've got the objectives and things like that, and we've got a background scenario, and it's talking about testing connectivity, discovering PC information, and you can discover information about the default gateway devices, because we have the default gateway address, meaning I should be able to telnet or SSH. In this case, it's going to be telnet, and we'll talk a little bit about that, because one of the final reflection questions down here talks about what could we have done to improve on the network configuration. And I'm going to give you a very comprehensive list of some things we can consider, and some of those things you're going to see me do in this video as well. So again, we're kind of starting blind here, right? It's that ominous network cloud in the middle. I can click on the PCs and I can easily gather the PC information in terms of subnet, MAC address, IPv4 address, and the default gateway. So now we're going to try to go ahead and get over to whatever the default gateway device could be here. So we can simply, let me come down to the bottom, we can simply say telnet, and then I'm going to go to 192.168.1.1 because that is listed as the default gateway device. And it's from there that I can now use some other commands. And so here we are. I'm on branch-1. And this is important because I'm now on what I would assume to be a router, since it's my default gateway address. Now, the password was Cisco for the VTY line, and the enable password is class. And so we'll enter that in. Now I'm in privilege exec. I've moved from user exec to privilege exec, and it's here where I can say show version, right? If I'm interested in seeing, hey, what kind of a device am I on? We'll take a look. There is my iOS XE image, and I can see that it's an ISR 4300. Now, what other way could I check to see that information? And if you're thinking show CDP neighbor, you're absolutely right. I can see other information about other route or other devices to which I'm connected. And take a look here. I'm connected to a switch, and this is the branch 1 router, and then I connect to the hub router. Now, the hub router is also an ISR 4300. And as we work our way through, we'll notice that the routers are all ISR 4300s. And so now I've got some additional information here that I can start to piece together. Now, when I'm looking at this output, I should probably be thinking to myself, switch 1, B1, right? So switch 1, branch 1, and then this branch 1 router connects out to a hub. Well, let's take a look at the running config. And let's see what we've got here. If I come down to the interfaces that are being used on this router. So gig 000. So that is the interface that is the default gateway interface on this router. Now, I've got a suspicion that that could be connected to the switch. And again, if I go back up here and let's take a look. Switch branch 1, my local interface that connects me to the switch branch 1 is the gig 000 interface. And on the switch, I'm connected to gig 01. And so, in other words, what we're looking at right now is we've got PC1 here, and I'll just put a 1 in here. We have PC1 connected into branch, and I'll just put BR1, branch switch 1, and that is connected into the branch 1 router. Now we know that the branch 1 router has a serial interface that's going to connect it to a hub router, right? Okay, and so that's kind of what it looks like right now. We know that this is gig 000 here, and this is gig 01. We can see that in the output of the show CDP command. Now, if I've got this information, I've got the IP address of that interface right there, there's not going to be an IP address here, right? Because the switch, we're probably looking at a VLAN setup. So how do we get onto the switch? I don't know the IP address of that switch. Well, again, this is where CDP comes into play. And let me take a quick step back. You can also see that I'm running OSPF. Now, one of the things you may notice right out of the gate is we have an OSPF network statement for the 192.168.1 network, the /24, on which the PC sits, but what are we missing here? There's a couple things that we're missing, right? And we talk about that reflection question at the end. What could we have? Well, where's our router ID command? Wouldn't we want to hard code that here for branch router 1? Where's our passive interface command for that gig 000 interface? We would want that as well, because there are no other devices out that gig 00 interface other than the switch. So there's a couple things to think about there. So now let's take a step back here and let's say show CDP neighbor detail, right? This is going to give me the information I'm looking for with respect to switch branch 1. We can see it's a 2960. Capabilities are a switch. It's just a layer 2 device here. And then we've got the IP address of that device, right? So now it's like this treasure hunt. I can now go to the switch. And when we go to jump on the hub, take a look at that. There's the hub router's IP address. So first, let's jump onto our switch, which is 252. So let's go ahead and say telnet 192.168.1.252. It takes a second there. Cisco is our VTY password to get logged in, and the enable password is class, and that is universal in this configuration. So now I'm on switch branch 1. Well, I've got some questions here, right? My questions are, to what interface does PC1 connect? And do other things connect to this branch 1 switch? Because again, maybe PC2 connects to it, or PC3, or PC7. We don't know. We just see sort of this innocuous network cloud out here to which all these devices are connected in, and we've got to sort that out. So what are some of the first commands that you might run? Well, how about show IP interface brief to take a look and see what we've got here. And we take a look at our interfaces, we can see that fast Ethernet 01 is up. Okay, well, we know that that's not the interface that's connected to branch 1. The interface connected to branch 1 is gig 01. And so a quick survey of the status of the ports here, of the Ethernet ports on this switch, clearly shows that there's only one thing connected to fast Ethernet 0, or I should say there's one thing connected to fast Ethernet 01, and we know that the router is connected to gig 01. So now it's a pretty good clue that PC1 connects into fast Ethernet 01. The problem here is, how do I confirm that that is actually what is connected? Because maybe it's not PC1, maybe it's something else. So what commands could we run to sort that out? Well, what if I said show run, right? Now this is probably not the command we're going to use to get the information, but take a look at fast Ethernet 01. You'll notice there's no configuration on that port. Let's keep going down here. There's no configuration on any of these ports except for the switch virtual interface for VLAN 1, and we have an IP default gateway command. Now remember, that is the default gateway for the switch, right? That is not routing traffic, transit traffic. This is for control plane traffic, like if I telnet from the switch or if I SSH from the switch. That is sort of like, think of it as like the default gateway statement on a PC. Tells the PC where to go if I don't have a more specific route to get there. And for the switch, that is what that command accomplishes. Now, for VLAN 1, we have our switch virtual interface. We know that's the IP address we came to when we telnetted here, and here is the password on the VTY lines, right? So, one of the first things you should notice is this is in plain text, right? Maybe we should do service password encryption, right? Another reflection question enhancement that could be put on here. So let me ask you, what VLAN are all of these ports using? Well, remember, if it's the default it's VLAN 1. And since there's nothing else indicated there, we can see that all of the ports are in VLAN 1. So no VLAN has been configured. Another reflection question answer. We should never be using VLAN 1. It's the default native VLAN. It should not be used for PCs. So we could create a VLAN 10. And basically what we saw is, and let me change the color here to red, what we're seeing, right, is I'll put the router, so this is just the branch 1, and here's branch switch 1 right here, is the PC connects into Fast Ethernet 01, and then everything here is just VLAN 1, right? And then that gives connectivity to the router, which is 192.168.1.1, and then this router has a serial connection into what you're going to see is this hub router in here that's providing all of the connectivity between all of these different devices. So when we look at this, we now have a really good idea as to what the configuration looks like over here for PC1 getting to the hub router. And so then we would fill our information in up here, and we would put in the branch 1 switch. We would put in the branch 1 router. We would put in all the information from all the interfaces that we found, and we could drop it into a tabled sheet like this, or like I'll show you my diagram, which I did up in OmniGraffle, which is Visio, basically Visio for the Mac. All right, so everything is in VLAN 1. So again, reflection question is right out of the gate, we should be using a different VLAN. What's the other thing we may consider? Well, Cisco best practice is don't allow the ports to sort of auto configure themselves as an access port or as a trunk port. We should hard code the port. So here are some recommendations that I'm going to make. So let's come into global config. Let's go into interface fast Ethernet 01. And I'm not going to do any VLAN work here, but I'm going to say switch port mode access. We want to hard code it as an access port. Remember, that doesn't change the VLAN. If I don't specify a VLAN, we get the default VLAN, which is VLAN 1. What else would you put on here? How about spanning tree port fast? It's a host-facing port. Why not? Right? We want to have that on here. Spanning tree BPDU guard enable. We want to have BPDU guard on that port to protect that port from a switch being plugged in. Now, before I talk about port security, remember, we still need to verify that, in fact, PC1 plugs into Fast Ethernet 01. And I'm going to use the MAC address to sort that out. So what if I say, do show MAC address table? Well, take a look here. It is a very quick and easy way for me to take a look at the MAC address to be 100% certain that what plugs into Fast Ethernet 01 is, in fact, PC1 using the MAC address. And on that same token, wouldn't we want to have switch port security on? Absolutely we would. And then what about switch port security MAC address sticky? Here's another way, and again, this is sort of the long way to getting the MAC address on the port to see what that MAC address on the port is. Again, show MAC address table is going to give it to us right away. But this is another way that you can see it, and it enhances the security. Now, if I don't say switch port security maximum, oops, get in there, MAC address, sticky, I wanted maximum, completed out there, maximum. If I don't put anything in here, what's the default? Absolutely, the default is going to be 1. So let's go ahead, I'll just set it to 2 so that we can see that it's configured and that it's on there. And the same thing, switch port security violation mode, we've got protect, restrict, and shutdown. What's the default? Shutdown is the default. But let's say I'm just going to protect it here, right? Because we want to see some information in the config to see that we have actually got a much nicer configuration here for Fast Ethernet 01. So now let me go ahead and say, show port security interface Fast Ethernet 01. What do we see? Well, take a look right there. we've got that last source address in VLAN, and it confirms again that we're using VLAN 1, and you can see D737, those were the last 4 in the MAC address for switch 1. And so hopefully now you've got a good feel for how you can attack each of the PCs and to track them down, or to track down the devices to which the PCs are plugged into, what that looks like, and how you can create your diagram. And again, I would recommend sort of maybe even sketching it out like I did on a piece of paper with a pencil or a pen and start drawing it out. So let's log off here and we'll get back onto the branch 1 router. So we saw that there's an OSPF configuration. So show IP OSPF neighbors. And you can see here that I have a single neighbor to which I'm fully adjacent, but there's no DR/BDR and the priority is 0. Well, we know that that's because it's a point-to-point network type. We've got this point-to-point serial interface here. And again, I can see my neighbor's router ID here. That's the neighbor ID is the router ID field. But what are some of the things that we could do to enhance this? Well, again, like I said, if I say do show run, and this is part of your reflections that you should be thinking about when you look at these configs, and take a look here at router OSPF 10. So let's get in there. We'll say router OSPF 10. Whoops, sorry. I'm going to say router ID, and it's branch 1, so we'll just say 0.0.0. Oops, sorry. And you could actually use extra zeros, right? Remember, the extra zeros are free. And again, it's not going to show that. It's simply going to show do show run. It's going to show it correctly. It'll get rid of those extraneous zeros, but you can put extra zeros in there if you make a mistake, and it's going to go ahead and take that command anyway. Now, I'm also going to say passive interface gigabit Ethernet 000, because I don't need OSPF hello packets going out that LAN-facing interface. You wouldn't want that. So there's 2 things you can do to the OSPF config to tighten things up a bit and to add a little bit of sanity. Now, remember, I've changed the OSPF router ID. So what do I need to do? Clear IP OSPF proc to clear the process, right? And we're going to see that it's going to go down and then come back up, show IP OSPF neighbor, and it'll probably take it, you can see we're in the init stage here, probably take it a few seconds to do that. But when we get onto this hub router, and you can see the IP address to which we're connecting to get to that hub router, or that we're going to telnet to, that is the address we'll use. And there, you can see it's full and up now. So now let's take our next step here. And so now what we're going to do is we're going to telnet to, excuse me, to the hub router, right? Keeping in mind that, again, if I was to say show IP interface brief, we can see that the hub router is probably, since it's a /30, 192.168.0.1. And take a look there. Connection is open, so we'll put the VTY password in of Cisco, and we are now on the hub router. So let's go from user exec to privilege exec, class being the password there, and now let's say show IP OSPF, show IP interface brief. And we want to take a look at the interfaces. Now take a look at this. You can clearly see here that there are a multitude of serial interfaces that have a number of /30 networks here, and we can confirm that by saying show run. And so the hub network, the hub router, I should say, is definitely the central point of that network cloud up there, into which a whole bunch of other routers are connecting. So what if I say show IP OSPF neighbor? What do we see? Well, take a look at that. I'm running OSPF, and here we go right here. There is the new router ID on branch 1. So we can see we're running OSPF with branch 1, and we can probably assume that these are other branches, maybe a branch 2 or a headquarters branch or a development branch or something like that. And so you'll find that out as you get onto these other routers. And you can simply do that. Remember, the left-hand side, this is the router ID. here is the IP address column. So let's go to the first one there, and let's see, 192.168.0.6, type in Cisco, and lo and behold, it's branch 2. What if I go to 192.168.0.10, type in the password Cisco? It's the HQ branch. So you can now start to see how this network is going to evolve and how it's going to be built out. Now, that's the hub router, and you can see we've got this internet server that's out here. Well, if we go back and take a look at Show IP Interface Brief, you can see that all of these 192.168s probably lead to internal devices. However, the gig 000 interface does not go to an RFC 1918 address. It goes to a 192.0.2.1. And my guess is that that is probably on our way out of this cloud to the internet server. In fact, let's telnet there, right? Again, telnetting to each of these devices using the different commands, 192.0.2.1. It's all about moving to each of the devices, and sorry about that. I wanted to, oh, I'm on the hub and I wanted to go into privilege exec here, sorry. And then, and it's not taking the password, a typo. Okay, so we had some typos there. So telnet to 192.0.2.2, and there we go, because we're 2.1, so chances are it's 2.2 on the other side. And we'll say password Cisco, and lo and behold, it's the ISP router. And if I say show IP interface brief, what do we see? Well, we see that there's only two interfaces on this ISP router, the one that faces the hub router, 192.0.2.2, and the one that faces the segment for the internet server. And so your job now is to go through each of these PCs here and to build up a network diagram and an addressing table here. And now let me go ahead and share with you my network diagram. And as you can see, there is quite a bit going on here. And once you get through the activity, this is where you should be. Now, I would double check to make sure that none of these IP addresses have changed from each time you launch the activity. Sometimes packet tracer activities, IPs and subnets will change. So you're going to want to walk through all of this. Now, this is the diagram that we're going to be using to troubleshoot packet tracer 12.6.2, right? And I've got to be honest with you, this would make an amazing sort of final hands-on activity in packet tracer. To put something together like this, maybe put in some troubleshooting, maybe some typos for troubleshooting, but to provide the learner with the steps saying configure OSPF on this router, right? Originate a default route off of the hub router, which if you look at that hub router, that is what it is doing. So we've got, I mean, this is a really great activity. I really enjoyed working through this diagram in order to get everything laid out and prepared for packet tracer 12.6.2. All right, well, again, that is going to do it for this activity on packet tracer 12.6.1, where we started our troubleshooting challenge by mapping out the entire network using CDP. And now the final thing I'm going to mention are, again, let's talk one last time about those reflection questions. The router ID for the OSPF routers, you should hard code that. Passive interfaces across the line. Use VLANs other than VLAN 1. You'll notice that there are other VLANs that get used, but maybe you should change that in this diagram. Passive the interfaces that are LAN-facing interfaces in OSPF. Change the VTY lines to only allow SSH, configure keys and users, maybe even AAA, and an ACL on those VTY lines to make it so that the branch 1 router will only accept connections via either Telnet, or ideally SSH, from PC1. And then port security. Now, you may come up with other ideas as well, and be sure to include those in your reflection. All right, thank you so much for watching. I really hope you enjoyed this video, and now we move on to the final packet tracer activity in the ENSA course, 12.6.2. Thanks again for watching, and I hope to see you in the next video.